A very good morning to all of you. This is 11th video from the unit motion. In the last video, I was discussing the numerical problems based on the concept of circular motion and uniform circular motion. Here in this video, we will know some of the terms related to the circular motion and one derivation establishing the relation between linear velocity, angular velocity and radius of circular path. So first we have here linear velocity. It is denoted by v and defined as rate of change of displacement, that is v is equal to displacement by time. V is equal to s by t and its SI unit is meter per second. Moving ahead, angular velocity. It is denoted by omega and written as W. Angular velocity is defined as the rate of change of angular displacement. That is, angular velocity is equal to angular displacement by time. Symbolic form we can write omega is equal to theta by t. By the symbol theta we denote the angular displacement. The SI unit for angular velocity is radian per second. Now the next important term is angular displacement, and as I have told you, the angular displacement, it is denoted by theta. It is defined as angle formed by the radius at the center of the circular path in a given time, and this angle is formed from the ends of an arc. So here from the definition we have angular displacement is equal to s by r, where s is length of the arc and r is the radius of circular path. The SI unit for the angular displacement, it is radian, denoted by RAD in short. Now we will establish the relation between linear velocity, angular velocity and the radius of circular path. So here is the question. Establish the relation between linear velocity v, angular velocity omega and the radius of circular path r. Or in other words, we have to prove it here as v is equal to omega r. So now in order to prove it, let us consider a body which starts moving from point A on the circular path of radius r. After t second, it reaches to the point B, covering a linear distance of s, that is length of arc AB is equal to s, which makes an angle theta at the center, that is angular displacement is equal to theta, as shown in the figure here in this. So in this figure, r represents the radius of circular path, s represents the length of arc AB, that is distance moved, v represents linear velocity, omega represents angular velocity and t gives us time interval, that is time taken. So now we will derive it. As we know, linear velocity v is equal to distance moved by time taken, that is v is equal to s by t. Let us consider this as equation 1. Angular velocity is equal to angular displacement by time taken, that is omega is equal to theta by t. Consider this as equation 2. Angular displacement, it is equal to length of arc by radius of circular path, that is theta is equal to s by t. Let us consider this as equation 3. Now, using theta from equation 3, in equation 2, we have omega is equal to s by t into r. And as we know, v is equal to s by t from equation 1. So using that, we can write omega is equal to v by r, which finally gives us v is equal to omega r. Moving ahead, let us discuss some differences. And here in first, we have difference between linear motion and circular motion. So for linear motion, the body moves along a straight line. Whereas in case of circular motion, the body moves along a circular path around a fixed point. Second point of difference, the direction of motion does not change in case of linear motion. Whereas in circular motion, the direction of motion changes continuously. Third point of difference, in linear motion, if the body is moving with constant speed, there is no acceleration of the body. Whereas in circular motion, there is acceleration of the body even if the body moves with constant speed. For the next difference, here I have difference between uniform motion in a straight line and uniform circular motion. And the very first point of difference is, in uniform motion in a straight line, the direction of motion of an object does not change. Whereas in uniform circular motion, the direction of motion of an object changes continuously. Second point of difference is, in case of uniform motion in a straight line, if an object moves with constant speed, the acceleration of the object is 0. Whereas in uniform circular motion, object moves with constant speed but its direction of motion changes continuously. Therefore, velocity of the object having uniform circular motion changes. Hence, the motion of the object is accelerated motion. Thank you for today.